Hello everyone, this is Dr. Young here, and in this video we're just going to talk about how to name some fairly simple alcohols. We'll do a couple of more tricky ones near the end with some stereochemistry or multiple functional groups, but I just want to give you a basic idea of how to name out the alcohol. So the biggest thing, right, is that you're just going to change that alkane ending of whatever from the ending from E to OL. So for example, if you have ethane, the idea is that we're going to drop that E and you just change the E to an OL, so this would be ethanol. Ethanol, right? So we drop the E, change it to OL. That's all you really need to do. Now, the alcohols do have a priority, so they're not like alkyl groups or halogens, for example, which have no priority whatsoever. They do have a priority, so you want to give them the lowest number possible, right? So if I take a look at these three molecules here, I've got, the first thing is I just have 1, 2, 3, 4, 5 carbons, so that's our pentane. And if I was to name this one in the middle, right, it's a pentane, but with an alcohol on it, so I know it's a pentanol. But this one's also a pentanol, right? Because it also has 5 carbons and it has the OH group, right? So this is also pentanol. Clearly these are not the same molecule, right? One has the OH in the middle of that 5 carbon chain, one has an OH at the end of that 5 carbon chain. So like with other things, right, I do need to have, to number the parent chain. You want to give it the lowest number possible. In this first example, it doesn't really matter if I start left or right. Either way, that OH is going to be on the 3rd carbon, right? So I can number this 1, 2, 3, 4, and 5. Or if I switched it went the other way, it would be 1, 2, 3, 4, and 5. It doesn't really matter which way. So you could call this 3-pentanol. What I do need to mention, though, is while you will see 3-pentanol written out all over the place, IUPAC, that International Union of Pure and Applied Chemistry, has changed the official naming structure to where you put the locant, which is that number, right in front of the functional group you're talking about. So you can see 3-pentanol, but technically pentan 3-ol is what you can also see, and is technically what IUPAC is looking for, where you put the locant right in front. So either one of these, for me at least, is going to be fine. I learned the first way, so that's how I tend to like just name things automatically. I'm trying to retrain myself to say pentan 3-ol, but it's just pentan 3-ol sounds so much worse to me than 3-pentanol. So you're just going to be aware of that, be mindful of it. Technically, the second way is more correct. With this last example, right, it's not the same one. I don't have the OH on the same number. It's not on carbon number 3. I'm definitely going to label this carbon 1, 2, and 3 so that I have the lowest, my OH is on my lowest carbon. So this would just be a 1-pentanol. So we have a 1-pentanol versus a 3-pentanol. Or like I was saying, right, you want to keep in mind that you could also name this pentan 3-ol. Pentan 3-ol, and I'll put the 3 in there. That's really all there is to naming alcohols. You just want to make sure you give them the lowest number and that you change the ending to OL, basically. So let's look at some examples. Oh, wait, so before we go, that's actually not pentan 3-ol. That should be pentan 1-ol, excuse me. So pentan 1-ol. Okay, perfect. Now some examples. So I've got my parent chain here. Looks like I've got carbons 1, 2, 3, 4, 5. So this is another pentane thing here. And I need to decide how am I going to number this molecule? Am I going to start the numbering from the left-hand side or the right-hand side or the top? I do have 2 branches with 5, right? I could go, let me just draw this here. I could go this direction and call that 5. Or I could go this direction and call that 5. And if you remember, right, if you have a tie, you always pick the one that has the more groups. So I'm going to go with the purple route, because that is going to give me more groups, more substituents. And as far as my numbering goes, am I going to name the carbon with the bromine number 1, so I have a 1-bromo? Or am I going to name it from the other side so that I have a 2-hydroxy? Or, sorry, not a 2-hydroxy, a 2-ol, whatever, a pentanol, 2-pentanol. And remember that the OH has priority, methyls and halogens have 0 priority, so I just care about the alcohol. So I'm going to call this carbons 1, 2, 3, 4, and 5. And then I just name all of the things that are coming off of it, right? It looks like I have a alcohol at carbon number 2. I have a methyl, I have a 4-methyl. And I have a 5-bromo. So then put that all together in alphabetical order, right? And I should get that I have a 5-bromo, 5-bromo, 4-methyl. And then again, you can say 2-pentanol, but pentan-2-ol is technically more correct. Pentan-2-ol, because that's where the alcohol is at carbon number 2. Or like I said, you could say 2-pentanol, same thing. If I number this chain here, again, my OH has to be in the parent chain, so I know that my parent chain has to be this. That's the longest chain I can get, and it has the alcohol in it. So even though technically, if there was no alcohol here, I would have gone up into this T-butyl group because it has more substituents, I have to just totally ignore that because the OH needs to be in the parent. So this would be my carbon 1, my carbon 2, 3, 4, 5, and 6. So I have a hexanol. And if I look at my group here, right, I have a 3-T-butyl group, 3-tert-butyl. A 3-tert-butyl group was this whole guy. Or you could say a 1,1 dimethyl ethyl, either way. So put that all together and I have 3-tert-butyl, T-butyl, hexan 2-ol for this molecule. So 3-T-butyl, hexan 2-ol, or 3-T-butyl, 2-hexanol. This one down here is cyclic. Maybe you can pause for a sec, see what you can do with this one and the next one. The last one has stereochemistry. The bottom one is cyclic, so don't forget how to name those. I'll give you 1 sec. Go ahead and pause, take a crack at it. So hopefully you took a crack. Right? Remember with the cyclic compounds, you can start at any one of these carbons in the ring. But again, because the alcohol is the most, has the highest priority, this has to be my number 1. And then if I go clockwise or counterclockwise, my next thing is at 3. But if I go clockwise, my next 2 things are at 3. So I'm going to go 2, 3, 4, 5, because that'll be a 3,3-dimethyl. And so I'll just go clockwise again. Number 1 has to be where the OH is because it's the only thing with priority. Even if you think you can get lower numberings going somewhere else, it doesn't matter. The highest priority thing is carbon number 1. So my alcohol is at number 1. So in this case, I have 4-chloro. And I got a chlorine at the 4 spot. And now I have a 3,3-dimethyl. And now I have a cyclopentanol. Cyclopentan-1-ol. Sometimes you'll just see pentanol, so cyclopentanol for the parent. And that's if they omit that 1 here, if they omit that 1 right there. That's just because they're assuming, if you don't see a 1 written there, you assume it's at the 1. So if I didn't see the 1 here, I was like, oh, I don't know, where's that alcohol? You assume carbon number 1. So sometimes people won't say that. Like, no one ever says 1-ethanol because it has to be at the carbon number 1. If someone just says butanol, you assume that it's 1-butanol, for example. So 4-chloro, 3,3-dimethyl, cyclopentan-1-ol. And then lastly, in this example here, now I have some stereochemistry. So just same rules apply, nothing really different. You just need to make sure if something has RS configuration that you say if it's RS. And so in this case, my parents would be 1, 2, 3, 4, 5. And then it looks like here I've got an ethyl group and an iodo group. So I've got an iodo and an ethyl that I need to name. And so for this compound, I have 3-ethyl, 1 iodo, pentan, 2-ol. And I need to not forget my R or my S configuration, right? So if you do your R and S configuration again, you'll see that this ends up going clockwise. So this should be R, right? Because the oxygen weighs the most. The iodine weighs more than either of those carbons do. So it's my number 2. Then this is my 3. My H is in the back at number 4. So I'm going clockwise, hence R. So this would be R, 3-ethyl, 1 iodo, pentan, 2-ol. Those are all fairly straightforward-ish examples, right? You should be able to do these types of problems. The biggest thing is to remember your stereochemistry. If you see a dash or a wedge, make sure you say something about it. Now, if you get more complicated molecules, ones with more functional groups than just alcohol, right? You want to remember that alcohols have a higher priority than alkenes and alkynes, which have roughly the same priority. Alkenes are slightly higher than alkynes if they're tied. But alcohols have a higher priority than alkenes. So even though, like you may have learned previously that alkenes, you'd start like, oh, that's number 1, that's number 2 to keep your alkene really low. We're not going to do that. All we care about is we're just going to look right at that alcohol and see how we can make that alcohol the lowest number possible. So that means this is my number 1, my number 2, 3, 4, 5, and 6. And then I can just name that, and you follow the same sorts of rules with alkenes and alcohols as normal. So it's kind of like this would be a hexanol. So first it'd be a hexane if it's just an alkane. But then it has an alcohol on it, so I have to change the E to the OL. But you also probably learned, right, that if it's an alkene, it's not hexane, it's hexene. So this would be a hexene all. So I changed the A to an E also. So one's to account for the alcohol, one's to account for the alkene. So this goes from hexane to be a hexene all, because you have to say where the alkene is and where the alcohol is. So if you put the locants in there with the numbers, you'd say hex, where the alkene starts at carbon number 5. So hex 5-ene, and then where's the alcohol? The alcohol is at carbon number 2, so 2-all. And so the name for this molecule would be hex 5-ene 2-all. You might also have seen other ones. You could also see something like 5-hexene 2-all would have been how we used to name things. But again, IUPAC prefers this way, where the locants are right in front of the functional group that you're talking about. And then one more real quick. Again, you can pause if you want to take a crack at it yourself. But we're just basically, right, got my number 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know that this is a nonane derivative. Only I see in my nonane I have a methyl I need to mention, and then of course I have the alkyne that I need to describe, and then I have my alcohol that's on here. So doing that, right, so instead of a nonane, it's going to be a non-ine because we have the alkyne, non-ine, and we change the N to OL because there's alcohol, so non-ine-all. Maybe I'll write that all out again. So right, it would be a nonane if it was just a hydrocarbon. If we add the fact that it has a triple bond, it would go to non-ine. And if we add the fact that there's an OH, it goes to non-ine-all. Non-ine-all. And so that's going to be the parent name, and we need to put the locants in there. So I've got a 5-methyl. 5-methyl. And then the alkyne starts at carbon number 6, and the all is at carbon number 3. So this would be 5-methyl non-6-ine-3-all, which is a terrible sounding name, but that's the IUPAC name. So that's kind of how you name alcohols. That's the gist. So if you have any questions or comments, you can leave them down below. Definitely do lots of examples in the book and in the worksheets. Happy studying.